Assalamualaikum warahmatullahi taala wabarakatuh, and very good day to everyone. Okay, so today's lecture I will explain about the next properties of nature of light, which is the refraction. I will explain furthermore related to refraction. Okay, so refraction basically happen when the light pass through into a different medium. If you can see from this image A, okay, the diagram A, the incident light or incident rays pass through from air and then towards a glass. So we know there are different medium between air and glass. This can cause the ray to be refracted. Okay, so this is the refracted ray and this is the incident ray. So basically we know that the incident angle is always from the ray to the normal. Here the normal is always perpendicular to the plane. So this is your incident angle or theta 1, and then the theta 2 is the refracted angle. In this diagram also we can see the reflected ray. So light also can be reflected. In this case the incident ray pass through the air and then reflected. So in this case the reflected angle theta I is equals to theta reflected. But for theta incident is not always equal to theta refracted. So the angle of refracted is depends on the velocity and the medium of the interface. So for a ray oblique incident on the air glass interface, so the refracted ray is bent towards the normal because velocity 2 is less than velocity 1. In this case, we know that the light have their own velocity, which is speed of light is 3 times 10 to the power of 8 meter per second. When the light pass through a certain medium, the velocity will be, so this one is considered v1, and then when the light pass through a medium glass, so velocity is v2. In this case, v2 is always less than v1. Due to the different velocity, the ray will be bent toward the normal line. Okay, so all ray and the normal lines in the same plane. So in the light incident in this block, for the real image for the laser light, if you can see here, the number one is the incident ray. This one the incident ray. The number 2 is reflected ray. The number 3 is the refracted. So we know that if the light pass through a different medium, so this is air and this is a glass or lucite block. So due to the different medium, so the ray will be reflected. So the ray will bend both when it enter block and when it leave the block. So if you can see here, the refracted ray here also can be considered as an incident ray for this block. So incident rays for this block, and then the number 4 is the reflected. So this phenomena is always happen in the light situation if the light pass through a certain medium. Okay, so the details that I have explained just now. Okay, this is the incident. Number 1, the ray is the incident ray. Number 2 is the reflected. Number 3 is refracted. Number 3 is refracted. And number 4 is internally reflected in the lucite. And the last one, this one also considered the refracted ray. Because the light from glass, this is the incident ray from glass, and then refract to the air. Okay, right. So due to the different medium and different velocity of the light, okay, and it will cause the different angle will be produced. So part of energy is reflected and part of it enter the second medium. So the path of light ray through a refracting surface is reversible. If the ray is originated from B, it will be refracted to A. So that's why in the previous image, we can see here the incident ray from the glass can refract to the air. Okay, so when in air speed of light c enter the medium, so in this case we have a glass. So as I mentioned just now, the light have the velocity speed around 3 times 10 to the power of 8 meter per second. When the light pass through into a medium, so the velocity reduced to 2 times 10 to the power of 8 meter per second. So when we emerge into air, speed of light again. When light enter a medium, may encounter atom absorb light, excite electron or sedate electron, radiate beam light to another atom, etc. So the absorption and radiation cause average light speed to decrease. So the basic info we need to understand, if the light pass through a certain medium, the velocity will be decreased. Okay. So here the different, if you have the different angle of incident and also the different value of velocity as I mentioned earlier. So V1 is from air, so we have C equals to 3 times 10 to the power of 8 meter per second. So when it pass through a glass, so the velocity will be reduced. So in the previous slide, it stated reduced to 2 times 10 to the power of 8 meter per second. So if velocity 2 is less than velocity 1, the refracted ray here is bent toward the normal. So the things you need to understand, if the velocity 2 is less than velocity 1, the refracted ray is bent towards the normal. But then from glass, if the light pass through again to air, okay, this situation B. So when glass pass through to the air, so this is considered your incident angle. This due to the velocity, this is velocity 1 and this is velocity 2. Velocity 1 is less than velocity 2 because velocity 2, the light is in air. So we know that the speed of light is 3 times 10 to the power of 8 meter per second. So that's why for the V1 less than V2, so the refracted ray is bent away. So the refracted ray is bent away from the normal. So here the theta refracted. So here the different, the important things you need to identify what happened for the refracted ray and also the angle, refracted angle, if the velocity V2 less than V1 or V2 greater than V1. So here the analogy, the real phenomena for the refracted. So if you can see here, if you have a concrete surface and grass, so grass we consider as a rough surface. So the concrete considered a little bit smooth. So when this barrel, consider this is V1, this is your V2. So V1 is greater than V2. So which is this is high velocity V1, and then when the V2 is less than V1, so the barrel will be turns towards the normal. So here the normal is always perpendicular to the plane. So this is the real situation phenomena that can be related to the refracted of light. Okay. And then next, the importance formula we need to understand is about the index of refraction. Okay. So index of refraction, in general, the speed of light in any material is less than speed in vacuum. So this is the previous that I have mentioned. So for different medium, they have a different velocity or different speed. So refractive index also is due to the different element or different medium have a different refractive index. You can see here, as a wave move between the media or medium, its wavelength change but frequency remain constant. We know that the light have a wavelength, specific wavelength. So for a different medium, they have a different. When the light pass through a certain medium, they have their own specific wavelength. So hence the index of refraction with symbol by n is given by speed of light in vacuum divided by speed of light in medium, which is we given by n equals to c over v. Okay. So as the wave move from medium 1 to medium 2, the wavelength change and frequency remain constant. So basically the formula is come out from the F equals to c over lambda. C is a velocity. That's why we can relate F equals to v over lambda, or v equals to F lambda. So this is referred to medium 1 and this is referred to medium 2. Since the frequency is same, finally we can simplify F, and then we get the relationship v1 over v2 equals to lambda 1 over lambda 2. So as the light travel from one medium to another, the frequency does not change. So the frequency is always same, but both the wave speed and the wavelength do change. So the wavelength and the speed is change, different. So from here, if we have this another relationship, v1 equals to v2, v1 over v2 equals to lambda 1 over lambda 2, and we have another relationship, n equals to c over v. N is a refractive index. So when we substitute v equals to c over n, so we substitute v equals to c over n into this formula, we get this relationship, and then we simplify, and finally we get lambda 1 n1 equals to lambda 2 n2. So this is referred to medium 1, this is referred to medium 2, different medium. And this since if the light strike into the interface wavefront, they have their own angle. So the angle is the different angle is due to the different wavelength. So we can say that sin theta is directly proportional to the wavelength in the medium. So we have the relationship sin theta 1 over lambda 1 equals to sin theta 2 over lambda 2. And then when we simplify this relationship, we can get sin theta 1 sin theta 2 equals to lambda 1 over lambda 2. So from here, we have lambda 1 over lambda 2 also equals to n2 over n1 from here. So from here we have lambda 1 over lambda 2 equals to n2 over n1. So from this relationship, so we substitute here, and then finally we can get sin theta 1 over sin theta 2 equals to n2 over n1, and finally we simplify the formula, n1 sin theta 1 equals to n2 sin theta 2. So here the final formula, we call it as a Snell's law of refraction. So for a different medium, they have the specific incident angle or theta 1, and then refracted angle or theta 2. So this one refer to medium 1, and this refer to medium 2. As I mentioned just now, for different medium, they have their own specific refractive index. Okay, so this is the Snell's law, right? So here the details for some index of refraction or refractive index for different medium, if you can see here. And normally glass is around 1.52, air is 1, and water is 1.33. So these are the value, the constant value that can we use to find the angle of incident or to find the angle of refraction. That's all for today. Okay, thank you so much.